Hello, you guys. Section 4.1 for pre-calc. One of the first things I want to look at is that this thing is called the unit circle, and it's a circle on a coordinate grid where the radius is 1. So it's going to be a little tiny circle that's sitting right at the center of a regular Cartesian coordinate grid, so a regular graph. 0 degrees is here, and positive rotation is going to be upwards. Negative rotation is going to be downwards. So that's going to make this 90 degrees, 180 degrees, and so on, moving around the unit circle. And it's called a unit circle because your radius is 1. Okay? Next piece of information I need to go through with you guys is, I don't know if I want to say unfortunately, but I'm going to have you guys memorize this, and you might remember this from last year. Resize it a bit, so I have to move it around a little less. Okay, so here goes. Doing degrees first. Just let me pull this down a little more, get a little more centered. Okay, degrees, so like I was doing just a minute ago, 0 degrees, 30 degrees, 45 degrees. And if you guys don't put the degree symbols on, it means radians. It's a different way of measuring. So yes, you have to put the degree symbol on these. 90 degrees, 120 degrees, 135, holy cow. Thought I forgot that one. 150 degrees, 180, 210, 225, 240, 270, 300, 315, and 330 degrees, and finally to come full circle, you got 360 degrees. The other piece of information that you guys have to have, and I guess before I erase it, that idea that this is a negative rotation, so this would also be negative 30 degrees. Or this would be negative 90 degrees. Okay, so rotating the same amount around, this would be negative 270. Or back here would be negative 360. Okay, so swinging positive, swinging negative. Next piece of information you guys have to have are all the coordinates. Well, if this is a radius of 1, this coordinate is 1, 0. And I'll be giving you guys blank unit circles as quizzes. And most often, it's these 4 corners that kids will get wrong. So please pay attention. Don't make these mistakes. The radius is 1. These 4 corners are the easiest. It's on a regular coordinate graph. That this is your y-axis. This is your x-axis. Okay. So then this coordinate up here has got to be 0, 1. This coordinate over here is going to be negative 1, 0. This coordinate down here, it's going to be 0, negative 1. Without giving you an explanation of why these next ones are the next ones, I'm just going to work on the idea of just memorizing them. This position right here is going to be square root of 3 over 2, 1/2, so 30 degrees, that's the coordinate. And using what you guys know about this quadrant, the coordinates are plus, plus. This one is minus, plus. This one is minus, minus, and this one is plus, minus. So the x value, the y value, negative x value, positive y value, and so on. The distance you're up is your y value. The distance you're over is your x value. This coordinate is the same distance, it's just left rather than right. So that coordinate is negative square root of 3 over 2, and you're the same distance up. So it's the same distance up as this one, 1/2. This coordinate right here, you're the same distance back as this one, so negative square root of 3 over 2. But this time, you're the same number of units down, so it's negative 1/2, which also matches with the idea that everything in this quadrant is negative, negative. And then if you come across, this is the same distance over as that one, so you're at square root of 3 over 2, but you're below the x-axis, so it's negative 1/2. So everything here has the same numbers. So on this box. All right. If you want, I can get rid of this box, make life a little bit cleaner for this next piece of work that we do. Going on for 45 degrees, the coordinate is square root of 2 over 2, square root of 2 over 2. And what you should notice is this distance over your x value is the same as your distance up. That's why the two numbers are the same, meaning the x is the same as the y. Not y, they're square root of 2 over 2 and square root of 2 over 2, just that they're the same number. Now push it across. Here, your x is negative and your y is positive. So at 135 degrees, it's negative square root of 2 over 2 and positive square root of 2 over 2. Push it straight down. Hey, that's not bad for a vertical line for me. Okay, they're both negative. Square root of 2 over 2, negative square root of 2 over 2. Okay, and now push it across. The x value is positive and the y value is negative. The last one is at 60 degrees, excuse me. What I need you to notice about it is this distance over your x value is the same distance this one was up. Because this triangle here, this triangle that's here at 30 degrees, if you stood it up or laid it over, whichever, if you want to think of it standing up right here, it's the same triangle. So this distance is the same as that distance. So your x value is what was the y value, and vice versa. What was your y, what was your x, is now your y. Now push it over. Negative 1/2, positive square root of 3 over 2. Push it down. Negative 1/2, negative square root of 3 over 2. Push it over. Positive 1/2, negative square root of 3 over 2. Okay? Another way to remember those two, 1/2 is 0.5, and square root of 3 over 2 is about 0.9. So, square root of 3 over 2 is bigger than 1/2. When I give you, say, this coordinate, you're going to go, okay, it's not a 45. The 45s have the same numbers. It's not a 45. So it's got to be a choice of 1/2 square root of 3 over 2 or square root of 3 over 2 1/2. But what I just got done saying is 1/2 is 0.5 and square root of 3 over 2 is about 0.9. This one is farther left than it is up. So the x value gets the bigger number, and you're in this quadrant, so the x is negative. Okay, well, what about that one? You're not as far over as you are down, so the x value is smaller and the y value is bigger. Okay, not cutting the negative, but I think you get my point. All right, enough on the unit circle. Definition of measuring an angle in radians is theta, and that's pronounced theta, T-H-E-T-A-E, theta, equals S over R. S is your arc length. It's the length of arc that this angle is cutting off, that theta cuts off, and R is your radius. It's just the definition. And they're going to say, find the missing piece of information given this information. Well, you just fill in the blanks. Theta is on the left. Theta equals S over R. Theta is 3 pi over 4 equals R of 40. R goes on the bottom, so S over R, 40 centimeters. This is a proportion, so you cross multiply. 40 times 3 is 120 pi centimeters equals 4S. Divide by 4, and you get 30 pi centimeters is your arc length. Tells you how long the arc is. Okay? They're telling you S and R, so theta equals S over R. Theta equals 10 feet over 22 feet, and the units cancel, so you get 10 20 seconds. Now, one of the things you should notice here, guys, is my 10 is awful. Okay, besides that, is the units canceled. Theta is unitless. There are no units. So that's what I was saying on the previous picture. If you guys labeled something as 45, that's 45 radians because it has no units. Radians are unitless. They have no units because the units just canceled out. Okay, in order to use this theta equals S over R, this is the definition of radians. It is not the definition of degrees. So when you plug an angle in here for theta, it has to be in radians. And if you remember back from the unit circle, 225 degrees was hanging out right there. So I believe that's going to be 5 pi over 4. It's the same angle, 5 pi over 4. No, wait a minute. You guys wouldn't know this yet. Okay, so that's a hiccup. I'll explain that on section 4.2. All right, but just pointing out when you use this, if you ever use this, you don't have the equivalency yet for what the radian angles are, so I apologize for the mix-up. But that is still true, that in order to use this, you have to use the radian angle. So S is 6 inches over R. Finishing with it, you've got 5 pi R is equal to 24 inches. And to solve for R, you're just going to divide by 5 pi. Now, nothing reduces. Don't type in pi. It would just be R is equal to 24 inches over 5 pi. Okay, I think that's the last one for this page. Find the central angle in radians. Okay, theta is equal to S over R. S, R. Theta is equal to 31 inches over 12 inches. And the units cancel. So theta is equal to 31 twelfths. You're done. Now you're looking for the long way around. And the long way around arc length is 45 inches. Okay? It's still theta equals S over R. So 45. Almost wrote it upside down. 12 inches. And once again, the units cancel. Bam, bam. So 45 twelfths is your answer for your angle. I don't believe there's anything below it. Okay? Converting between radians and degrees. This will become easier to understand once you guys get a little more familiar with radians. Right now, just take it on faith why I'm doing this. You're going to when you're going from radians to degrees, what you want is on top 180 degrees is what I want. I'm wanting degrees. And the equivalent angle for that is pi. So you're going to multiply by 180 over pi. And in the next section, this will become more clear why in the world you're doing this. So if you guys are okay with that, I'll explain it then. The pi's are going to cancel, which is good because you want them to cancel. And then this is going to reduce, and you've got 20 degrees. So pi over 9 is exactly the same angle as 20 degrees. It's just measured in radians. Again, you're going to multiply by 180 over pi. Pi once again cancels. None of this is reducing. So you have 360 degrees over 7, or 3/67 degrees. 18/5. What makes it radians isn't that it has a pi, it's that it doesn't have any units. And I'm telling you it's an angle, right? So you're still going to multiply by 180 over pi. Nothing's going to reduce though. It's just going to stay 18 times 180, yikes, over 5 pi. And 18 times 180, not that we really need to do that for this, 18 times 180 is, it's kind of gross, 40 degrees over 5 pi. Okay, my degree symbol's a bit big. I'll shrink it down for you. Okay, degrees. So you just leave it. To convert from degrees to radians, you're going to multiply by just the reciprocal of this. Now, I want you guys to be a little more comfortable with this idea. That's a degree symbol. 12 inches is 1 foot. This fraction is worth 1. The top is the same as the bottom. Okay, 1 foot, 12 inches. That's still worth, these are reciprocals of each other, but they're still worth 1. I know it looks like 1/12, but because of the units, 1 foot. 1 foot is exactly the same size as 12 inches. Okay? I know this looks like two completely different numbers. They're reciprocals, and you guys are used to reciprocals being different. Okay? But because of the units, that this is the same size as that, it's worth 1. And the reciprocal of 1 is 1. So I'm multiplying these fractions by something that's worth 1. And when you want radians, radians go on top. When you want degrees, degrees go on top. Okay? So I want radians, so radians go on top. Degrees are going on the bottom, so they cancel. This does not reduce, so you have 25 pi over 180 degrees. Whoop, 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 whoop. 180. That canceled. 180 radians. Pi 180. Degrees cancel. And you got 127 pi over 180 times pi 180. So that'd be 312 pi over 180. And I don't think that that goes anywhere, but let's try. 312 divided by 180. Math, enter, enter. Oops. So that would reduce to 26 pi over 15. All I did was type this into my calculator. I got a decimal 1.73 with the 3 repeating, and then I hit math. Enter, enter. Enter, enter. And it converted that decimal back to a fraction. Okay. Let's see. Anything else? Next page. Oh, that looks like it. Wonderful.